Welcome to STEMinists Talk, a deep dive where we highlight the inspiring stories of women in science and computing. Today we're looking at the work of Daniela Rus.
Yeah, the pioneering first female director of MIT's Computer Science and Artificial Intelligence Laboratory.
Exactly. And, to start things off, I want you, the listener, to just imagine swallowing an ice capsule made of dried pig intestine, like literally sausage casing.
It sounds wild, right? But it's this incredible origami robot. So you swallow it, the ice melts inside your stomach, and the intestine unfolds.
Wait, it unfolds inside you?
Yeah, it catches slightly on the stomach lining, which creates enough friction so doctors can use an external magnetic field to steer a tiny embedded magnet. It literally crawls over the stomach wall, grabs a swallowed button battery, and drags it out safely. No incisions at all.
Okay, let's unpack this. So the material itself is doing half the work. We're going to dive into how she's completely redefining what a robot actually is. Because looking through the sources, this fixation on how physical materials interact with the real world started in a really unexpected place.
Communist Romania, yeah.
Right. She had scientist parents, loved the sci-fi show Lost in Space, but as a teenager, she was forced by the government to work 1 week a month in a locomotive factory.
Yeah, turning heavy steel screws from scratch on an industrial lathe.
Which is basically this gritty 20th century maker space. It taught her that all the abstract math in the world is useless if you don't have physical mechanisms to actually enact it in the environment.
Well, and what's fascinating here is how that sparked her whole body-brain paradigm. Like when her PhD advisor told her classical computer science was essentially solved, she connected those two worlds.
Right. Think of classical computing like a brain floating in a jar. You can do complex math, but it can't affect the world. Her factory experience made her realize the brain needs a body.
Precisely. You have to co-design the physical structure and the software to solve problems together. And that realization caused her to actively reject traditional rigid body kinematics.
Because for decades, the industry standard was heavy, caged factory arms moving with absolute precision.
Right, exactly. But Rus looked at the messy, unpredictable real world and realized rigid robots just break or hurt people when things go wrong. So she pivoted to soft robotics and adaptable machines.
I am struggling a bit with that jump, though. Why intentionally introduce, squishy materials and chaotic momentum into the engineering instead of traditional perfect precision?
Because the real world isn't a controlled laboratory. Soft compliance allows robots to survive collisions and adapt. Take a robotic fish, SoFi. It's made of soft silicone, which naturally flexes with ocean currents instead of fighting them.
Oh, right. And didn't they do something wild with the head to handle deep-sea pressure?
Yeah. To stop it from crushing, they filled its 3D printed head with baby oil. It swims through Fiji's coral reefs without damaging them, and they actually steer it using a waterproofed Super Nintendo controller.
Wait, really? A Super Nintendo controller? That is amazing. But she also uses rigid materials in entirely chaotic ways, like with the M-blocks.
Oh, the M-blocks are brilliant. They are these tiny 5-centimeter cubes, but they have no external limbs to move around.
So how do they move?
They use internal flywheels spinning at 20,000 RPM. When a flywheel abruptly stops, it transfers that angular momentum to the cube, causing it to literally jump through the air.
Oh, wow. So they just use pure momentum.
Exactly. And because there are magnets on the edges of the cubes, when they collide, they snap together. They magnetically self-assemble into different structures like staircases or bridges.
So whether it's a jumping magnet or a squishy silicone fish, the common thread is adaptability. Soft compliance makes robots safer, which means they don't need to be locked in cages. They can bump into you and safely act as collaborative teammates.
And that transition from isolated machines to collaborative teammates scales up to her broader philosophy on artificial intelligence. In her book, The Heart and the Chip, she proves that collaboration vastly outperforms replacement.
Because human intuition and AI processing work better together.
Yeah, she provides a massive data set showing that when human pathologists diagnose cancer alongside AI, the error rate drops to just 0.5%.
It fundamentally challenges the fear that technology is here to replace us. Her vision is entirely about augmentation and inclusion. And, looking at the broader landscape of STEM, this belief highlights exactly why diversity in tech is so crucial.
Right, because right now women make up only 22% of AI professionals worldwide, which is a dangerous bottleneck.
It really is.
Rus argues that if we are going to build technologies for the greater good, we absolutely must have diverse voices in the room designing them. You can't build inclusive technology with an exclusive team.
Absolutely. The history of technology is deeply driven by women whose collaborative visions actively shape our future, even if they aren't always the names in the textbooks.
Yeah, that representation matters so much.
It does. And if you are listening to this, especially the girls and young women out there, you belong in STEM. You are equipped to be creators, not just consumers. As Rus herself paraphrased it, see not just what technology can do for you, but what you can do for technology.